Alright, here's an update on my little device. I have a Cornell Dubilier 200 volt 7700 microfarad huge cap that came out of a treadmill. I have my 17.5 turns to about 18, and then the wire schematics are here. Basically, that's how they're connected. I'm using this MPF 102 FET driving the actual coil itself. And then I have a MPS 8099, or you can use a 2N2222A or 4401 or any of the NPN transistors. Give you a good shot on that. This is a 25 ohm rheostat. It's turned all the way down. This is a 10,000 ohm linear taper resistor, and it's turned all the way down too. Plus, you can see I have another resistor in here. I believe that's 5,000 ohm. And then the way these are configured, this is all charging off of one wire, the white green wire here on the output. And I'm using the orange as a bi-filar L1. And you see how it's connected. The MPS 8099 has the power coming in to the transistor and to the coil at the same time. At any rate, so right now I'm sitting at 0.388 volts. You can see that, and no milliamps. So I'm going to connect the battery. Looks like a mess, but what's connected is what's connected. Alright, here we go. Connect up this. Watch this baby fly. 0.2, you can see the settings on 2 milliamps. I'm using 0.2 milliamps, and now I'm already at 1 volt. It climbs significantly fast, and it'll go way up to like 100 volts. There's no noise. It runs, see, we'll get some scope shots here. Let's see what's coming out of the positive. You can see the scope shot. Very, very off. So it seems to be very erratic with the MPS, the MPF 102 transistor. We're already at 2.5 volts almost. We're only using 0.24 milliamps. I'll just tell you, I've been using, instead of the MPF 102, I've been using a TIP 120 or 122. Now that gives me about, you move the decimal point over twice. So right now that would be usually at about 31 milliamps, but this climbs the same. No matter what, this keeps climbing at the same rate, no matter pretty much of any of my adjustments. Let's see if I can get. It's better to take scope shots when there's nothing actually coming about here. See, what I'm showing is very strange. With the MPF 102, I cannot get a straight signal. It looks like the signal is variable and it keeps spiraling. But as you can see, it's somewhere around 9.5, 10 kilohertz. Let's see if we can filter this baby a little bit. Okay, so we add the filter on, but see, it's reading. If I have a spinning nature of energy, then it's just not going to read it correctly. And I can almost guarantee that when I take this off, so now see, look, this can easily influence just anything. You put my hand over it, but it does slow down the growth on the capacitor. You can do the same thing with putting your hand over the coil. Changes it. Touching any of the leads just singly, like, let's see, I'll touch the negative. You know, down to 0.5 milliamp, and climbing, you know, relatively quickly. But then I take it off, see how much faster it goes. And what happens is this will keep going up until it reaches about 20 volts, and then it'll start going back down. It'll use less milliamps. And this is quite a large capacitor. Right now, if I take it off, let's see, we'll get up to, I can keep it on here until it gets to about 10 volts, and I'll show you the real energy that's coming out of the system. See, I think as the back pressure builds, see, if you notice, the milliamps are already going down, and we're only at about 10 volts. There's nothing else connected here. I just got my wires dangling from the meters. You know, it looks like a mess, but there's nothing else connected but what I have here. We have capacitor, you know, you got colored wires here. And that's going to the other side of the meter. As you can see, now it's 11 volts. Climbing steadily. Now this is a 6 volt battery. 6 volts, 8.5 amp hour. But now remember, I have it turned down completely 25 ohms, so it's about 5 volts coming in. And of course you see the milliamp usage. How fast it's growing. So okay, we're about there. 10-minute mark is coming up. We got 12 volts. We're going to pull these off. Okay, we're going to disconnect everything, and for the grand finale, there you go. 12 volts, 7700 microfarad.